Okay, so this is Leetcode number 72, that is edit distance there. So what is the given in this question there? We have the two string word1 and word2, and what we need to require, we simply return the minimum number of operations required to convert word1 means to word2. So what is the done in this question? We have given these two string there, this is string 1, this is string 2. What we need to do, we have to convert this string 1 to string 2. And like how to do this? For doing this, we have the three operations: either we have to insert, either we have to delete, or either we have to replace any of the character there. Okay, so let's testing how this test case goes on. This is our horse number. Okay, so this is a horse and this is a rose. Let's say if I have to start from where. Okay, so how it simply what we in this question, there are the many of the how we do this simply. Let's we can say this way, we simply eliminate, or we can simply delete all of the characters and simply insert all of these characters. So this is nothing but the n operation for this, m operation for this, by using since n for its length and there is a m for its length, but it is asking me the minimum number of operations, so that by which, so now we need to think about like how to do this our optimization operation such that it gives me minimum operations. So how to do this? So here if it has to start from this, so how first of all it replace h with a r, so now it become the rows, so there's a one operation done. Okay, now what is it is to done, he simply remove this r from here, so it become rows, so it takes the operation number 2. Now what he has to do, it removes the e there, so now it becomes the ros, that is our the targeted string 2 there. So how many of the operations are required to converting from the s1 to s2? So there's nothing but the 3 operation. So this is the minimal answer possible. These are the minimal operations possible for conversion for this word1 to word2. Now coming for this question, there's a let's say this is the intention and this is execution. Okay, so I'm coming for this case. Okay, so what is the given in this is for our previous question, so don't confuse it. So there's a one word intention, there's a and what's the s2 is nothing but, let's separate it by, I don't know how it is. Why is okay. So this is our s1 and s2, and since we know very well how to do this part, first of all I have to explain how to do you have seen in this question, there's firstly it has to simply remove the t from here. So after removing t, it become intention. After it has to replace the I with E, then N with X, then N with C, then U. So simply after it this operation, these are the minimal possible answer there, 5. So by this conversion it becomes the S1 to S. Okay, now we can say one thing, what is the given in this question, we can say at every position we have the choices, how with our choices we can say if our the characters are matching there. So in that condition we can say if our characters are matching, so it means we there's a no operation we can say no operation required. So we simply move our both of the pointer, since in this type of question we have to simply associate two indexes there. Let's say these are index the index number, here I am using the I, here I am using J. These are simply pointing to this string, so this can be handled very well by this index there. Okay, now coming to this. Okay, so there's two things there, if the characters are matching, so means we don't need any kind of operation, we simply move our I pointer and J pointer, and if the condition arises, means there's a no character are matching there. So in that situation we can have 3 point we can have 3 options there. Either I can say either we have to insert, either we have to delete, or either we have to replace. Okay, so only these are things possible. So this is basically given in this question. So what is the thing, or what is the intuition behind this question? Since we can say at every step we are making decisions, so whenever decisions exist, so what's the recursion comes into the picture. So it means we should go the recursion along the way. And it's like since I'm using the recursion, so there's a need for defining of our recursion state there. So how to do? So I'm using the f of I comma j. So like what's the meaning, or what's the definition for this? So this is nothing but it gives minimum operations to, I can say, to convert our this the string, this is two string, word 1 word 2. So like don't confuse it, I'm using there's a string as s1 there and s2 there. Okay, so this is nothing but for the conversion of s1 where it is indexing from the 0 to I there, and what we need to, we have to convert this into our string 2 there. So that is nothing but the s2 there, and there's 2 till the index number 0. Okay, so this is the basically definition of our f of I comma j. And like what we need to find, we simply need to find f of n minus 1 n minus 1. Similarly there's m minus 1. Okay, and you don't have to confuse about it. This is the length n, length m here. Okay, so like given in this question, there's a horse and horse conversion to rows there, and there's a similar intention conversion to execution there. Now okay, so at every step we have to check this ij, and now I in the further cases I explain like how our ing are updated in these individual cases there. But before it, let's we can wait a second. Okay, so this is our start, we can say this is our starting string there, this is our the final string there. So we have to move our starting to final. So for this we can first of all solve the explicitly base case for it, like what are the handle cases, what are the boundary cases there. We can say if the I is become less than 0, means we simply moves our I pointer here and simply moves our j pointer here. So we can say if our I pointer is 0, it means we can say our s1 is simply exhausted. So what it means? So in that condition, what's the only thing we must so in that condition I can say we must insert remaining characters of s2. Okay, so now let's say let's say in that case there's a I is going there and there, and j is along goes to there and there, and let's say in any of the case if I goes to beyond the 0. Okay, so in that situation, so what is the only possible operation? Neither we can delete because no characters are remaining there, and neither we can replace. So the only operation is to doing the insert, and since you can do whatever the operation, it takes the 1 unit, or we can see it takes the 1 work over there. Okay, so we simply what we have to do, so let's say this string is exhausted. So whatever the remaining string of the s2 there, we simply insert all of the characters of s2. So that means that is our the operation required. So we can say in that case we simply have to return there's a j plus 1, and like you don't have to confuse why the j plus 1, because let's assume this I goes beyond the 0. Okay, so now there's nothing characters remaining, and there's what are the characters here are, there's nothing but the okay, so there's a since j is pointing to, there's a 8 characters there. I think there's a 3, there's a 6, 7, 8, 9. Okay, 9 characters there, and j is pointing to 8, so that's why we have to return j plus 1 there. Okay, in that condition, like this is the case 1 there. Was the another case? In another case, let's assume our j's pointer is going beyond the 0, means j is become the less than 0. So in that case we can say our s2 is exhausted. Okay, so we can say we must remaining characters of s1. Okay, like it is all again, it is understable. Okay, So let's assume if our let's say there's a case arises when our j is goes to beyond the 0. So like how to do this, we simply remove all of the characters from the s1 also. So that means we simply use the delete so that means we simply return I plus 1. So these are the two base cases. Okay, now since we use our recursion here, so that's our recurrence relation. So how we do this? So these are the two cases, if our character matches and if our characters non matches. So in the case if our character matches, so what we can do in this case, so here we can say our f of I, it is nothing but it is becomable as f of I minus 1, I can say the j minus 1. Okay, and I can explain you very well how to do this. Okay, let's say if I'm starting from here I and j, since here the n and n are same, so no need to do any of the operation because we are reducing our trying to reducing our operation, so we don't have to extra burden over operation. So we simply move our I pointer here and our j pointer to here. Okay, so that's why I have to call for f of I minus 1 and f of j plus 1, and it is simply plus 0 because no operation are required for this. Okay, now checking for this case whenever our characters are not matching, so there's a 3 operation. Now we have to do 3 operation, and now how to our I and j update in these cases? Now let's say by using this example, let's say if our O row matches, so this falls in category 1, so again move our both pointer there. Now again it is same there, so we need to move our pointer. Now again it is t and t same. Okay, now it moves to our pointer I there and j here. Now we see here's our n, here's u. I can explain here again. Let's explain it very well. So it is come. Okay, let's say here it is our s1 there, and so what's the thing here? Let's say our string is I and t, there's a e and there's n. And what is our s2 is, it is nothing but the e, then x, e, then c, then u. Okay, and let's say we are standing at here, so this is our I pointer and this is our j pointer. So since these are not matchable, so how our operations are working here exactly? So we have the 3 cases, either we can insert, either we can delete, either we can replace. So now calling how's the each of the operation working here. So if I'm talking about the insert, so what it means? Insert means, let's assume we can this is our I pointer there and this is our j pointer. Okay, now since there's n and we want u at this position, can we assume we can simply add up our virtual u there? Okay, like this is our virtual u. Okay, so if we are to simply insert a new character, that is nothing but the same as of this character, so this is virtual. So what it means? Now since this is our desirable, so our I, so after it we since whenever we are meeting our targeted character, we simply move our I pointer to left side and j pointer to left side. So let's say if I create this new character there, so our I pointer, since it is matching with it, so there's I moves to left, but it still exists it already places it here, so there's no need to move our I, but now j is meeting here, so now there's a we can say one thing here, that our j is moving to here. Okay, so what it means, I'm trying to say, in that case we simply no need to move our I pointer, but our j pointer is moving to our left side, means j minus 1, because now you can see very well, here is our I, here is our j. Since we have to insert a new character, now these are matches, so our I is goes to left and j goes to left. So I is already in the left, so no need to move it left, because if we do it in our left, so n is escapable in this question, so it gives me wrong result. So since we are making the inserting this, so we assuming let's say this is we are inserting a virtual character there. So we are assuming our pointer is already virtually pointing it, and after inserting our I is going to left, but it is already in that position, so no need to update our I pointer, but J pointer updates. Okay, so this is the case when we are talking about the insert operation. Now we have to calling for the delete. So how this delete operation works here, and now after it we can call for the replace here. Okay, let's say this is our replace, and now see how to do this part. Okay, let's erase this part there. This is I there, and this is the J. Okay, so there's the condition when we are standing at here. This is I and this is J, our portion. Now this is N, this is U, and we want U here, but this is not meeting the, so means now we want to do this like this operation. So how we do this? So after deleting, if we have to delete this part, so what it means, we simply, why it is not okay, so what it means, simply our I pointer moves to here, but we don't need to move our J pointer because we want this character, and we simply skip this character, we get rid of this character. So that's why we simply need to move our why is it goes on there. So here our I -1 I can say, and the J pointer is still remain the same there. Okay, so this is the case for our this situation. So there's a why it is not. Okay, now let's assume if like don't confuse it, this is understandable as a N there, because this is discussed as our previous question there. Now what's to done in this question there, the third operation remaining in that situation, what we have to do, this is our I, this is our J. Since this is N and this is U, these are not matchable, we want to do this operation. By this operation, this N becomes so what it becomes, this is cutting, and now it becomes the character U. So it means these are meetable. So now we can update our I pointer and simply update our J pointer. Why it is doesn't. Okay, so it means we can say our the operation of replace is nothing but the, this is f of I -1 and there f of J -1. Okay, so by this, these are the three steps for this if not matching there. Okay, and we can do one thing here, let our f of I comma J, it is nothing but the, since we do the one operation, so that's why we have to add the one operation. And what are the minimum operation in between insert, in between delete, in between replace, so we have to simply exert this in our f of I comma J. So this is our question here, and like I don't think that we need to make our recursive tree because we already do in our previous question. So like this is more clearly understandable in the question. So now coming to the coding part here. Okay, since we after making the DP tree, we are seeing that many of the states are repeating. So by this we can say we can use DP here. Okay, wait a second. Okay, so this is our brute force here. This is nothing but the same as I already explained in the my compiler part here. This is a main function, we simply call the solve function. This is for the index 1, this is for the index 2, means I1 and I and J. Okay, there's a I and J are passing. If our I goes less than 0, means we are talking about this situation when our I is less than 0, means x1 is exhausted. So in that case, all the remaining thing is insert all of the remaining characters of S2, that's why return J plus 1. Similarly, if J is less than 0, simply delete all of the characters, means I plus 1. Okay, now if the characters are matching, call for I -1 J -1. Now if characters are not matching, means 3 operation, so we have to simply write 3 operation, and what are the minimum, is it fall in this category, and there's a 1 plus, we have to return this. This is the brute force. We don't have to bother about since there's a time complexity is simply exponential, and they said Why exponential? I already explained in my previous videos. Like why? Because at every index we have the three options. Okay, in the first condition with the three operation, so that's why we can already also say like what's the time complexity for it. This is nothing but the m plus n. Okay, and what's the time complexity is? It is nothing but the n plus m here. This is nothing for the recursion stack space there, because in worst condition it has to use all of the stative. Now to optimize it, we use the memoization version. In this is still the same already. The code is the same. Simply initialize the dp vector, and there's a index 1 and index 2, means I and j are varying there. So what's the offset for I and j? This is nothing for the n, and this for the m, so that's why n into m dp vector here. So all this dp is passing in this main function, and this is the definition of function. This already remaining the same. So what's the time complexity for this? This is nothing but the n into m because of the dp, and this again same as for the dp. So that's the question hour.